Question number 77. By evaluating integral of I square r dt, show that when a capacitor is charged by connecting it to a battery through a resistor, the energy dissipated as heat equals the energy stored in the capacitor. So when you have a circuit like this with a battery of voltage V, and let's say we connect this with a switch here, somewhere here, the current starts flowing, and that current varies with time, and the power initially the current is very high, so the current varies something like this. The current is very high initially, but eventually when the capacitor is fully charged, so this voltage V is here, voltage V here, so V voltage here, V voltage here, and the current stops eventually. So this is the graph of current I flowing through this resistor. So when the current flows through this resistor, there is a power is dissipated across this resistor, and that will also vary. This power dissipated as heat, and that power is given by I square R, and the power is nothing but the energy per unit time. So if we are talking about the energy dissipated as heat in this resistor in the time delta t, we will give it as, call it du, that is I square R, the power, multiplied by dt. And therefore, if we want to know how much energy is dissipated as heat, we integrate this term from 0 to infinity of this term, and this is I square R dt. And we know that this current I varies as I naught e to the power minus t by RC. I will write it again here. I is equal to I naught e to the power minus t by RC. So I square is I naught square e to the power minus 2 by RC, and we have this R term here. I naught is nothing but the initial surge current, and it's given by V by R. Voltage is V here on this end of the resistor, and the other end of the resistor we can think of to be at 0 voltage. So the initial surge current will be V by R, and that is what we keep here. I naught square is V naught square by R square. R square and this R cancel, so we get V naught square by R integral of e to the power minus 2t by RC dt. Now this becomes V naught square by R. The integral of this whole term is equal to integral e to the power minus 2t by RC divided by this whole term minus 2 by RC, differentiation of this whole term, and that becomes equal to so we can put a minus here maybe, and then this R and R cancels, so because V naught square 2 by C becomes C by 2, so this is V naught square by 2. When we substitute e to the pi t is equal to infinity here, you get e to the power infinity minus infinity, or 1 upon e to the power infinity, which is 0, and then when we put t is equal to 0, this becomes this e to the power 0 or 1. So now the energy will be finally given by half CV naught square, this U term, and that energy is the same as the energy which will eventually be stored in the capacitor.